Welcome, ladies and gentlemen, to Covestro at the K Fair. It's day number 2. Who's been here since day number 1? Oh, yes, I do remember you. You were here yesterday. Excellent. Do you by now have downloaded the app? Anyone who downloaded the app? Oh, good. Yeah, well, yes, of course. Good. Do you like it? Because it's not only the information about Covestro, there's also games on there, so you can really educate yourself while playing. For those of you who just realized that they want to, I can explain that later, because right now we're going to dive into the topic that is sounding like this. So, welcome to Covestro at the Car Messe, ladies and gentlemen. Covestro wurde 2015 gegründet, and it is going strong ever since. It is a world-leading polymers company, ein Unternehmen, das Produkte herstellt und ermöglicht, die wir überall in unserem Alltag finden. Und bei allen Entwicklungen wirkt Covestro eines: to push boundaries of what is possible, to make the world a brighter place. Daher meine ganz kurze Frage an Sie, quick question to you: what would make the world a brighter place from your point of view? What would you say makes the world a brighter place from your point of view, sir?
Freedom.
Freedom. That's not necessarily at the core of the offerings of Covestro, but it's a good choice. So, sir, what would you say? What makes your day a brighter day?
Environment.
Environment.
Yeah.
So a good, sustainable environment.
Yeah.
Excellent. That is a perfect choice for today, because that's what we're going to be talking about. And also, we're not going to only be talking about it. By the way, übrigens, Sie können wirklich auch selber Fragen stellen an die Gäste. You can ask questions too with the upcoming guests, because innovation is always about co-creation, right? So, Covestro möchte also erreichen, dass die Welt a brighter place wird. Und zwar in segments like automotive, construction, electrical and electronics industries, as well as wood and furniture, sports and leisure. Doch wie sieht das aus? Come and join us. Come, here's some places. What does it look like when innovation knows no boundaries? It is all present. Yes, just go here. It is everywhere, in the plant, in the lab, on your seat, in collaboration with colleagues, customers and suppliers, and along the entire value-added chain. Und wie das konkret aussieht, das werden wir nun erfahren, because now we'll be talking in plain English about CO2 slow go, or attractive building block for the plastics industry. And in order to answer this question, amongst others, I kindly invite to join me here on this stage Henriette Naims from the Institute of Advanced Sustainability Studies, Alexis Bazzanella, Head of Research and Project Coordination DECHEMA, and Dr. Karsten Malsch, Venture Manager CO2 Polyols from Covestro. Please join me here on our virtual stage. Sometimes they do get an applause, but I don't know about today. Do you feel like applauding them? Some real live applause, and a very important topic that you can smile about, but also we have to think about on a more serious note. So, Ms. Naims, what do you say from the perspective of the society, of the people that sit here? What about this whole CO2 discussion? What's the innovative power that sits in CO2?
Well, first of all, for our society, of course, CO2 is a big problem because we're emitting so much. But originally, for nature, CO2 is not a waste or not a waste gas. It's a feedstock already. So in photosynthesis, trees are consuming it and changing it into energy. And yeah, now the idea is to copy nature in that way and make CO2 a feedstock also for human products. And if we can copy nature in that way, I think it's very innovative. And it has potentials, hopefully, in some climate protection, potentials, but also, closing the loop.
Closing the loop.
Yeah.
So from your point of view, why is it so important for the chemical industry to deal with this topic and to find new solutions? Let's say copying nature might just be one of them, because nature doesn't do mattresses, but Covestro does with CO2. So why is it so important all of a sudden?
Well, CO2 is a future feedstock for chemical industry. Well,
Okay.
we all know that the plastics industry and essentially the entire organic chemistry relies on carbon feedstocks and needs carbon feedstock. And in essence, we're using fossil feedstocks at the moment, which is oil, naphtha, part of the oil fraction, natural gas, or coal. Well, coal less in Europe and Germany, but for example, in China, coal is a very big issue as feedstock. And if we are honestly trying to avoid exploiting more fossil feedstock in the future, and with all the drawbacks we have, like CO2 emissions and so on, we need to start closing carbon cycles. And well, there are limited options to do that. One is, of course, recycling of already existing materials, biomass, which is already used in many chemical products and also in the plastics industry. But that's also limited feedstock. And well, CO2 is available in abundance at the moment, and we have large industrial emitters, power plants, in essence producing CO2. Even if it's not a product, it's a waste for them. But chemical industry can use this as a feedstock. It's a carbon source which is available. And the idea is actually to utilize it.
Okay, and for that you need to communicate, obviously, with the people who think about it. Talking about communication, if you kindly just, because they all see your back and they like your back, I guess, but it's always more interesting to actually watch somebody speaking, so because we've got lots of guests over there. So, since I addressed you, Dr. Malsch, from the company's point of view, out of corporations with these people, what happens? How did you actually tackle this? I mean, we heard about sustainability from one guest as one of his big dreams when it comes to the chemical and plastics and rubber industry. So what do you do with CO2 to turn this into a sustainable future?
Yeah, right, Carl. I mean, you started it off by asking people what they believe makes the world a bright place. And that is exactly the question we ask ourselves at Covestro a lot. I mean, what we want to do is we want to make the world a brighter place. And we also think that a more sustainable world is immediately a brighter place to live in. And we believe that the way to achieve this goal is to go via innovation. And that is why we started looking into ways to use CO2 as a feedstock, because what Alexis explained before is exactly our position. I mean, as a part of the chemical industry, of the polymer industry, we are actually faced with the situation that we are strongly dependent on fossil hydrocarbons as a raw material. And at the same time, we're well aware of the fact that we need to close the cycles in order to be more sustainable. So we thought an innovation that would help us to reuse a carbon atom that has been part of a fossil hydrocarbon before and has been turned into CO2, for example, while generating energy. That such a process would really resonate well with our ideas, with our intentions, how to make the world a brighter place. That's how we started it. And now we're at a point that we are clear about CO2 is not a slow go, because in the industry, we do not like slow goes. We don't like slow movers in our supply chain. So we are convinced CO2 is an important feedstock of the future.
Before we get into some examples and what they mean, let me just check with the audience. Who of you actually knows of a product that is actually made out of CO2? Anyone here who has any idea what you can do with it when you turn it into a product? Since we have a lot of information flow to get going, because obviously it's not clear. So what do you do with it? I mean, what does it look like when you turn it into a product?
Well, in our case, you know, we at Covestro, we are one of the major producers of polyurethane raw materials. And when we started thinking of what we could do, what we should try doing with CO2, we immediately came to the thought of using CO2 as a raw material for the production of one of the components of a polyurethane system, which is a polyether polyol. So we found a way to introduce CO2 in the molecular chain, the polymer chain of a polyol.
Okay.
Now, what does that actually mean?
That would be my next
What
question.
it means is wherever you use such a polyol to produce something out of polyurethane, and polyurethane is extremely versatile, it can be used, for example, in comfort applications, and you're sitting on something like that. And I have to, as I've been sitting on that before, I have to admit there is more comfortable flex foam than the one you're sitting on. And you wouldn't like to sleep on that, but you can also use polyols to produce a flexible foam that is then later on used in upholstered furniture, in mattresses and things like that. This is all available to our technology.
Excellent. And before the guests get any ideas about, oh, they look great and they're actually sustainable and everything, so I'm going to take one with me. No, they are all alarmed. They will explode in your face when you do this, okay? So just keep them there. So, but you grab the mic.
If I may, I think it's worth mentioning that the idea of using CO2 in chemistry is not entirely new. And well, there's a very large global product which uses CO2, which is urea, of course, so directly integrated into ammonia production. And well, the CO2, which is originating from the fossil feedstock in this process, is then directly transferred to urea. And that's more than 100 million ton product per year already. Or let's say a very old example is salicylic acid. Well, for aspirin, for example, which is since, I don't know, 1865 a known transformation of CO2. Right. So it's not an entirely new idea, but I think the new approaches we have now, based on catalysis, for example, are really emerging into something which is much bigger and opens a large variety of opportunities.
Okay, so this is only one aspect. And before we move on, let me just double check with the audience. So far, maybe some things didn't make much sense for you because you are of a different opinion. You can phrase that because these people are also here to answer your questions, not only mine. So if there are any questions, you just raise your hand, even slightly, we can see. And we would sneak a microphone to you, and then you can ask your question and they can actually answer it. Because you try, well, you will. I hold you responsible to that. Okay, let's just see. Anyone who wants to ask a question so far with the stuff that we've discussed? Not at the moment. Not even the students in the last row. They're all happy. Excellent. Good. Good. Nod of approval there. So there's one thing that I would like to find out, though, from the gentleman sitting here. When you think about CO2, what associations do you have when you think about CO2?
Waste.
Waste.
At first, waste.
Okay, waste. Any other associations? More positive ones, maybe?
Yeah.
Not necessarily. I'm just asking.
No.
No. Okay, just waste. What do you say, sir?
Pipeline.
Pipeline. Okay. That could be not positive. What is your first association? CO2.
I like the idea you have mentioned about aspirin. As a former Bayer company, we are close to that and thinking about the other way around, coming from, so to say, a tree and make a medical out of that.
Okay, that was the politically correct answer. Now, your personal answer. What associations do you have when you think of CO2 in your everyday life?
Nothing.
Nothing. Okay. So, madam, what's your association when somebody mentions CO2? And
yeah, it's close to waste. Yeah.
Close to waste. Okay. Anybody who has anything that deviates from this? Oh, okay. What do you say?
I have a question, actually, which relates to what you're asking.
Okay.
CO2 is a very diffuse source. It's everywhere. So the economics of integrating that in the manufacturing of polyurethane must be a challenge, no?
Good question. Let's hope for a good answer. Dr. Malsch.
First of all, you're right. CO2 is all around the place. But nevertheless, there are significant point sources of CO2 where it really makes sense to take the CO2 out of an off-gas stream, for example. And as the question is normally asked, I'll start answering it before it is asked, where is your CO2 actually coming from? You may have heard that we are right now in the phase of starting up the first plant producing our material with a capacity of 5,000 tons at our site in Dormagen. And there in Dormagen is an ammonia plant that uses a lot of natural gas for the production of the hydrogen, and by doing so generates waste. And the waste is, in this case, CO2, and we take it from this a relatively CO2-rich off-gas stream. That's how it works there.
Question answered? Excellent, thank you very much.
I also want to add
Yes,
something.
yes.
Yeah, I've actually done an analysis for larger scale CO2 utilization, what sources could be relevant. And yeah, currently we have so much CO2 everywhere that it shouldn't be a problem to cover potential of CO2 utilization, even larger scale. But maybe in the future, if we manage to get our climate targets right, there will be less available CO2, but still there will be enough CO2. Yeah. And even from point sources.
For example, if you take I don't know, 1 gigawatt coal power plant, does that produce enough CO2 for you to have a plant manufacturing polyols from it? That's kind of what I'm trying to get a sense. Is that the scale we're talking about?
Coal-fired power plant? Yeah, I think there's enough CO2 to use it somewhere. But then you have another question, because if you take CO2 from a coal-fired power plant, then some people might be worried that you are actually prolonging the coal-fired power plant. And if we are phasing out, yeah.
The only reason why we are phasing them out is climate change.
Yeah.
CO2. So if you start using in plastics, maybe it's an answer.
Perhaps to add on your question, unfortunately, a 1 gigawatt power plant, coal-fired power plant, for example, produces much more CO2 than you would probably use in one of those processes. So there's not enough headache around to actually cope with the entire point source CO2 we have available.
But one of the major headaches that I just became aware of is that people have very limited associations when it comes to CO2. It's always waste, waste, waste. So obviously that's one of the reasons why we have this talk here, to inform people on a wider basis. But is that something that you really have to deal with whenever you do workshops with stakeholders and so, that you have to start changing the associations around this topic or the emotional upheaval that is connected to it?
Yes, it's an important point. It really depends on who you're talking to.
Right.
But at the IASS, we've organized some stakeholder workshops and also invited people from outside the technical community. So, for example, government representatives or people from critical environmental associations. And they, of course, have a very strong opinion on CO2. So there's a lot of misunderstandings if you talk to them about using CO2, because if they think about CO2, they think about climate change problem, and they have very high ambitions of the energy transition, complete 100% renewable energy, that there won't be any CO2. So you have to talk to them about it and really make sure that you understand where you take the CO2 from. And also, you need to, they always, when you have a CO2 utilization option, they always think that it's too small. It doesn't really affect climate change. And this is something it takes a lot of explaining and... Okay,
so now that we know what people think, what would you like them to think based on what is actually true?
Yeah, that's also a big topic for us. I mean, whenever we talk about the utilization of CO2 in our products, and we come with the example of the mattress. I mean, this is something that really you can think of as an end product. You really have a relation to an end product like that. And one of the questions that's quite often asked is, yeah, but what does it mean? There is CO2 in that mattress. People think of the mattress, the foam of something like a sponge. Does the CO2 evaporate from that every time I move?
Okay.
The answer, I mean, I'm standing in front of a well-educated chemical audience here today, so I think it's clear to everybody in this audience that there is a chemical reaction. The CO2 has completely disappeared. It's not a kind of a carbon capture and storage discussion. The CO2 is gone. It's for sure not coming out of that foam. But nevertheless, there is always this feeling, and therefore it is for us important that we do not generate kind of a new kind of chemophobia around a topic like that, because we are, while we're not saying we save the world and solve the CO2 problem, the problem of climate change? No, for sure not. But we contribute to introducing a circular economy. We improve the carbon footprint of our activities, and we also really need an acceptance for that. And we are willing to work on this acceptance by being very, very transparent. For example, during our project, we've been working together with IASS, with RWTH Aachen University, and we said from day one what we need is a very, very thorough life cycle analysis that makes it clear to everybody who wants to hear, who wants to listen, wants to understand that what we do really improves the situation, that this is not just a story. No, we are doing things right. So what I want to vote for is that everybody active in this field is as honest and open, but what we also need is in the more political arena that there is really acceptance for activities like this, and not just right from the start an adverse feeling around it. Leave me alone, it's waste, I don't want to hear about it.
Okay, since the three of you collaborate, and it's all about collaboration if you want to achieve such a major goal, what can you do to educate? I mean, how do you actually, the three of you and the companies and the bodies that you represent, how do you work together to achieve such a change in association?
Well, I think it's a lot of different elements. Transparency is very important, I think, in particular in communication with the public. And I guess it's to make clear the LCA part is a life cycle assessment part is a very important point, so that you can really show evidence that, well, you don't end up with producing more CO2 than you consume in the product, for example. So that's an important element. And well, you just need to, as the entire team, need to communicate and make clear what are the new approaches, what are the possibilities, are the potentials, but also to be very honest in terms of the climate debate on this. Well, you already mentioned it. We're emitting, I don't know, 35 to 40 billion tons of CO2 every year. And well, chemical products are more on the top in the million tons per year area. So, well, there's a large gap between that. So this is something we can't, we can't solve the climate problem and communicate that we will be able to consume the entire CO2 for chemical products.
Yeah. And what's also important is that we communicate early. There's not so many technologies. Covestro is one of the pioneers, I would say. But it makes sense to talk to people early and explain everything that is going on, but also listen to what their concerns are, and because we have to take them seriously. And yes, and also what I wanted to add to the last question was really the first connection when people talk or think about CO2 is always climate change. So it's kind of hard to get them to talk about resource and the resource broadening of the resource base or circular economy thinking. And that's also a very important potential of CO2 utilization.
Okay, let me just again double check with the audience. Anything that you want to know, any question marks that popped up in your head, just raise your hand. The three of them are still here. We could answer those questions. Way up in the last row, all happy over there, smiling, nodding, very good. We're going to write a test about that in a second, so you're just kidding. But what I'd like to know is, now you've started. Oh, by the way, is this mattress and the stuff, this is on the booth, right? Where can we find it? So if people just arrived, where can they actually find it?
Right at the booth, you will find the foam. It's green colored foam.
Okay.
That's not because of the CO2. It's just that you can find it easier. So it's on this side of the booth.
On the other side,
Come and see us there. Look and touch.
Look and touch and be surprised. What I would like to do is to be surprised by you as to what happens next, because as Patrick Thomas said during the press conference, anything that you can talk about is almost a reality. And as you can see and touch it, it is there. So what's going to happen next? What's the next step? What are you looking at next from your point of view, Mr. Bazzanella?
Well, I think we have just started to explore the possibilities of CO2 chemistry in the end. So I think in the polymer areas there are a lot of more things we can do. Building in CO2 as a building block is one point, but we can also use CO2 to build up, well, the major building blocks of chemistry and polymers, like, well, methanol, like olefins. There are a lot of possibilities, which unfortunately need a lot of energy. And by that, we need to honestly talk about renewable, or let's say carbon-free energy or electricity. There are more possibilities, I said. Usually, the higher the potential, the higher also the economic hurdle is. So that is something we need to cope with. So there's a lot of things to do in this area.
Excellent,
still.
but that's good news. I mean, if you have a future, then that means you can go on developing. What about you?
I can just add to what Alexis said, that research and development is continuing in Germany, but also all over the world. And a couple of plants have opened. I hope this continues, because these technologies will take some time to come to the markets.
Okay.
Our research is also continuing. Yeah.
And you're continuing to cooperate, which means what? What is your next step?
Absolutely. When we started in 2008 with what now leads to the product range of Cardion products, as we call them, obviously, we started talking about a dream reaction, dream production. And for us, the dream is definitely not over by having achieved where we are now. I mean, we always said if we want to make the world really a brighter place, we need to do more, we need to work more on the topic. That means more CO2 in the chain, more applications for the existing molecules, but also new applications. So there are new projects running together with cooperation partners. We're looking at a broader range of applications. We're looking at elastomers. We're looking at rubber type of applications. There is definitely more to come from our side. Stay tuned.
Stay tuned. You actually should stay tuned, ladies and gentlemen, because it's not over yet. We reconvene here at 4 p.m. today to celebrate what these partnerships achieve. It's going to be the Science Award that's going to be handed out later today at 4 p.m. So if you want to, you can drop by and see who actually won. We don't know yet, at least I don't know, but they don't tell me anything until I go on stage anyway. And secondly, you can really see what it means when this cooperation bears fruits. For now, I say thank you very much to our three guests here on stage. I hope we could enlighten you about whether CO2 is something to be dealt with or something to be reckoned with. Thank you very much. Have a great time. See you soon. Bye-bye.